going using it. పర్లేదా? ఎవరు ఓకే రవీంద్ర రెడ్డితో మనవాడగా ఎన్ని గంటలకి? లింక్ క్రియేట్ చేయమన్నారా? ఏమో గుర్తుకుట్లేవు అసలు. అది ఏంది ఒకసారి షేర్ చేస్తారా? ఉంది కదా మన దగ్గర యాప్ ఉంది. ఏదో ఉంది. ఏమది నాకు గుర్తులేదు. ఎక్కువ ఏముంది గుర్తుకోలేదు అంటారంటావా? పోయినసారి రీసెర్చ్ చేసావు కదా, ఒకసారి చెప్తాను అయితే. సరే చంద్ర, గుడ్ మార్నింగ్. ఏం బాబు నా ఫోన్ కలవట్లేదా? రెడీగా ఉన్నారా? సరే సార్ షేర్ చేస్తానండి అయితే. ఇంకా మరి మీకేం కావాలి? కో హోస్ట్ కావాలా? చంద్ర నీకు ఇవ్వనా కో హోస్ట్? వస్తా ఉందిలేండి. ఇది కాదు సార్, నేను ఇక్కడ మాట్లాడుతుంది ఎన్ఐటిఎం ఉందా? చూస్తాను. అంటే దాంట్లో పార్టిసిపెంట్కి ఆ పార్టిసిపెంట్కి పాల్గొన్నాం అంతే కదా సార్. లాగిన సెషన్ స్టార్ట్ అయినాకే కదా జరిగేది. ఇంకా ఇవ్వచ్చా? నేనే కూర్చోవాలి. వైఫై ఆఫ్ చేస్తాను. ఇస్తానంటే పర్లేదు. ఇప్పుడే గోపినాడు కానీ మన కూడా వాడుకోపా ఏం కాదు అన్నాడు. అందుకని నేను ఆగిపోయాడు. ఇస్తానంటే వాడేద్దాం. ఏముంది, పార్టిసిపెంట్ ఎక్కువ వస్తారు కదా, వాడు ఇబ్బంది లేదన్నారు సార్. పంపిస్తాను. ఏముంది, నేను నాకు షేర్ చేయాలి, అది షేర్ ఎక్కువ అట్లా అంటావా? లింక్ క్రియేట్ చేసుకున్నాను సార్. వద్దులేండి. వద్దులేండి సార్. ఇదిగోండి, నేను ఇప్పుడు యూట్యూబ్ కొట్టాను. ఒకసారి అది కొట్టరా? మీరు మొబైల్లో ఆన్లో ఉండండి ఎప్పుడో. యూట్యూబ్ ఒకసారి కనెక్ట్ చేశాను. అలా లింక్ ఓపెన్ చేయరా? ఇది వస్తుంది అనుకుంటే ఇంకా మనం వీ క్యాన్ షేర్ టు పార్టిసిపెంట్స్. వస్తుంది కిందదా? లాస్ట్ నేను పంపించున్నాను కిందదా? నేను షేర్ చేస్తాను. ఆన్లైన్ ఎఫ్టీపీ అది కాదు, మన EEE గ్రూప్లో పెట్టాను సార్.
నెట్ ఒక్కటి వచ్చేలా చూడండి చాలు. వస్తుంది సార్ వెంటనే వస్తుంది సక్సెస్.
పక్కన స్విచ్ కదలకుండా పెట్టాను మళ్ళీ చూతాయి.
అదే
అప్పుడు అక్కడ బాగానే ఉంది, ఇక్కడ ఎందుకు రాలేదని చూస్తే వర్క్ స్విచ్లో
ఇంటర్నెట్ స్పీడ్ భయంకరంగా ఉండాలి అసలు. ఎల్వి ఒకసారి యూట్యూబ్ వస్తుందా? ఇది ఈ స్క్రీన్ వచ్చిందిగా.
అది దానిలో పెట్టేస్తారా గ్రూప్లో?
ఆ గ్రూప్లో పెట్టింటేనే సార్ చూసారు, దాంట్లో కూడా ఉంది చూడండి, మన గ్రూప్లో ఎఫ్డిపి గ్రూప్లో కూడా అది ఓపెన్ చేయండి చూడండి మీరు దాంట్లో. మన ఎఫ్డిపి గ్రూప్ ఒకసారి చూస్తూ ఉండండి, వాళ్ళు ఏదైనా కామెంట్స్ పెడతా ఉంటారు.
ఒకసారి ఆయన గురించి అయితే కొద్ది మళ్ళీ ఒకసారి చెప్తాను ఏదో పార్టిసిపెంట్స్.
మీరు ఇక్కడ రండి ఒక నిమిషం, ఇక్కడ కూర్చొని ఏం చేయొద్దు, జస్ట్ ఇక్కడ వీళ్ళు అడుగుతూ ఉంటారు, అడ్మిట్ కొడతా ఉంటారు సార్. ఐడియా ఉందిగా మీకు?
నేను వాట్సాప్ అది కూడా ఓపెన్ చేస్తారా పార్టిసిపెంట్?
ఏం అవసరం లేదు, ఇంకా పార్టిసిపెంట్ గ్రూప్ దాన్ని టచ్ చేయి, ఇది టచ్ చేస్తే మళ్ళీ మీకు అది పోతుంది. మీరు పార్టిసిపెంట్ గ్రూప్ మీ మొబైల్లో చూసుకుంటాం.
నేను దీనిలోంచి డిలీట్ కమ్మంటారు మరి అయితే? ఇక్కడ ఉంటుంది కదా దీనిలో లాగిన్ అయ్యి దీనిలోంచి తీసి డిలీట్ కానీ
ఇది ఎగ్జిట్ అయిపోండి, మీరు ఇక్కడే కూర్చోండి. ఇదిగోండి ఇలా వస్తుంది, అప్రిషియేట్ చూడండి, ఇలా వస్తుంది, ఇక్కడ కొట్టాలి. కొట్టాం. ఇక్కడ ఈ వీడియో కాకుండా ఇది తీసేసుకొని దెన్ ఇక్కడ స్పీక్ అవుతుంది.
స్టార్ట్ అయ్యింది.
he came, huh? Okay. Just inform me whenever they comes, okay? I will come. I am starting this FTP, right? ఎక్కడ సార్ రాలేదా?
ఫోన్ చేయను
జాయిన్ కమ్మా సార్ 10:30 అయిపోయింది.
అప్డేట్ చేస్తాను. సార్ గుడ్ మార్నింగ్.
హలో,
జాయిన్ అవుతారా?
చెప్పండి సార్. అవును,
స్టార్ట్ చేయొచ్చా?
కొల్లా హనుమంతరావు ఆర్చ్ ఉంది కదండి మన మంగమూరు రోడ్లో కొల్లా హనుమంతరావు ఆర్చ్ ఉంటుంది కదా, ఒంగోలు అండి. అవును, నంద్యాల. ఇప్పుడు వర్కింగ్ వచ్చేసి ఒంగోలు వర్క్ చేస్తున్నాను. అక్కడ మన ఆడ రెవెన్యూ క్వార్టర్స్ మెయిన్ మా నాన్న వాళ్ళు ఉంటారు ఇక్కడ చూడండి, అక్కడ ఇచ్చేయండి సార్. 30/100 రెవెన్యూ క్వార్టర్స్. కాదు మరి 30/100 అంటే రెవెన్యూ క్వార్టర్స్. అట్లనా? అదే అని అర్థం ఇదిలేండి. 30/100 101 అది యాక్చువల్గా భీమా. అదేలేండి సార్. బల్పనూరు. నేను నా మౌలిచంద్ర నా పేరు. నేను ఇక్కడ వర్కింగ్ వచ్చేసి ఇక్కడ ఒంగోలులో క్విస్ కాలేజీలో ప్రొఫెసర్గా చేస్తాను. మా ఫాదర్కి హ్యాండ్ ఓవర్ చేయండి సార్ కాస్త. ఏటీఎం కార్డ్ అదే ఉంటానే. నిన్న ఊరు పోయినట్టున్నారు సార్. ఇవ్వండి సార్, 2 కాస్తాం. రైట్, అదే థ్యాంక్ యూ. రైట్ సార్, మంచిది.
Hello, welcome to all the participants for this 5-day online faculty development program. Yesterday also a lot of participants participated and we have a good response from the participants and we have taken the feedback also. So today's speaker is also Dr. Dipo Sarkar, Associate Professor, NIT Nagaland. Sir is doing a lot of great work in research. He has a great contribution, has great H index and I index in the research. He is having more than 400 citations and he is having the patents also. He has authored 2 books. In that one, Basic Electrical Engineering, which is mostly followed in the JDK for the civil mechanical students also. Yesterday's session also went very well. A lot of valuable information are provided. Thank you, sir, for providing information. Once again, on behalf of QISCET, I welcome all the participants for today's session. Now I am handovering the session to Dr. Dipo Sarkar, sir. Sir, you can continue, sir. Thank you.
Good morning, everybody. My voice is audible to all of you?
Yes, sir, you are audible.
Yeah, so yesterday what we have discussed, that part first I will explain, give a brief things, and after that I will start today's things. So yesterday we have discussed about the basic structure of distribution networks. Then after that necessity of the network reconfiguration. Then applications of graph theory in network reconfigurations. In that, we have utilized QISCET's maximal spanning tree algorithm, and from that we have from that discussion, we have found that uh, using that graph theory algorithm, we can able to find out the optimal uh, radial network which operates under uh, less power loss conditions, overall active power loss, as well as less amount of reactive power loss conditions, and as well as that voltage stability of the network which was obtained through that graph theory algorithm, uh, also it's better and it is acceptable also. As well as we have found that the time consumptions for finding such solution also less comparing to manual configuration. Now today we are going to discuss about applications of optimizations techniques in network reconfiguration, and after that we'll discuss about application of neural network as well as the machine learning in network reconfiguration. So the basic objective of this discussion is that how you can utilize your optimizations as well as uh, the artificial intelligence techniques in particularly network reconfiguration problem. That part we have to study, and once you have learned that part, you can even able to apply that algorithm. You can apply any of the optimization algorithm for such network reconfiguration problem.
Example.
Any of the research scholar can also do some further research on network reconfiguration applying any of the new optimization algorithm, or you may develop also one new optimization algorithm, and then you can implement that algorithm in the particularly that network reconfiguration problem. So this is and nowadays people are also very much interest to study about machine learning algorithm also, and you can utilize that machine learning algorithm for finding the optimal network distribution network. Okay, so that I'm just giving you just some initial talk, means initial starting to you, and the rest of the part is will be given to you such that you can implement it in your future work. Okay, with this I'm starting my the first topic, that is called the genetic algorithm applications in network reconfiguration for finding a optimal network which will give us a better voltage stable network. So now, as you know, the genetic algorithm is a most basics as well as the simple algorithm which are having some steps. First of all, what we are doing there, we are generating some initial population that can be randomly generated, uh, and then then we have to encoding the data into some digital chromosome, and after that we have to select the healthy chromosome from that. Then from that we have to do some crossover among the selected chromosome. Then after that, once again we'll make some mutation process, and in that after some repetition steps we'll get the best chromosome which will give you the better result. And finally, if the after some iterations, if the result will converge, then we'll stop our iterations. So this is the basic steps. I think those who are having the basic knowledge about the genetic algorithm, they can do. I'm not about very much expert particularly in that domain. I am actually mainly focusing here how you can formulate your problems with respect to network reconfiguration using genetic algorithm. So now you see, yesterday we have discussed about with the network reconfiguration using graph theory. In that time, as a case study, we have taken a 14 bus network for doing the network reconfiguration, and in that what we have assumed while we have started the network reconfiguration, we have assumed that the each of the lines having one sectionalizing switch which is having two state, one is on state, another is off state. Normally the sectionalizing switch is on condition, and whenever it is required we can change the status. So normally it is means closed operation, it is in closed position only, it is closed only, right, and means on only. Now you see, in our problem, in our 14 bus problem, we have that total 20 number of switches, because we are having 20 number of lines. Or else you can better, if you think about this is a distribution network, then for a distribution network we are having 20 number of feeders, but practically a 14 bus network is a a transmission network only. But we are assuming this network, we have modified this network, and by inserting some switches in the lines, and that lines arrangement, that switch arrangement has been given by this table. You see in X20 it's indicating the switch which is connected between node number 13 and 14. Similarly X19 indicating what, that switches one switch which is connected between line number 12, between node number 12 and node number 13, or you may say between bus number 12 and bus number 13. Similarly X18 has been arranged in between 10 and 11 number of node, right? So in this way we are having total 20 number of switches. Now our main object is what, our main object is to minimize the voltage deviation, of the buses, of the overall buses. See, what do you mean by voltage deviation? And whenever we are considering the system is a big network or maybe transmission network, that time we are thinking that about that time the voltage status can be monitored using some stability indicator. Okay, but in some previous researcher already developed some indicators through which they can assess the voltage stability for a distribution network also. That is also available. But in my case study, what we did, we have considered that that VD is the overall, that VD is the voltage deviation. Just I am explaining that part. VD, better here, VD is the voltage drop of the line, of the overall line during any switching states of the network reconfiguration. Okay, so here in the present study we have considered VD as a indicator for assessment of the voltage stability. So now higher value of the VD for a system considered as a less voltage stable compared to the less values of the VD of the system. Now if the VD is more, it indicates the system is nearby to unstable condition, or sometimes it is unstable also. And XI is the indicating what, the sectionalizing switches at ith line. Now here at line number 8, 9, 10 and 14 they are having some transformer. That's why we are not at all using there any kind of switch. So Pi is the active power loss of the ith line and Ri is the resistance of the ith line. Now see, with respect to the figure, you see we are having some transformer. Okay, so in that transformer we have not at all added any kind of switch, sexualizing switch. Now our main motto is what? To find network one network which is having less voltage drop, means we are having some kind of, you know, hello, my voice is audible. Here you see the Vd is indicating the voltage drop that was found from where we are having some rated voltage for each of the bus, and from that how much it is deviated, that value is given by that value is given here as a Vd. So this is the voltage drop, right? That Vd is given like that. Suppose for a particular bus we are having some rated value, say 9.8 9 per unit. Now if you have say 0.95 per unit, or if you have some 1 per unit, then what happened? Then that deviation here we are considering as individual Vd, and we are adding all the Vd from here, right? From that only we are getting that Vd value. Suppose if you have say 4 bus network, we have to calculate for each of the bus Vd, and then we have to make summations. Now that Vd can be calculated by Pi into Ri, where Pi is the power and of the ith line, and Ri is the power at Ri is the resistance of the line. That square root will give you the Vd, and that if we have say m number of lines, that we are making it that I equal to 1 to m, that summation will give you overall Vd. So now that we have to minimize that one. Now the thing is that, see, yesterday in my last discussion, what we did, we have discussed that we need some network which is in radial network, because the radial network having some advantages over mesh network. So during planning stage, that is why we are thinking about radial network. So what are the different advantages? That part I have discussed. Such the main advantages of the radial network is what? It needs less amount of conductor. That is the first thing. Then the coordination and protection and coordination is very easy, right? Then overall short circuit current also very less for radial network. So these are the different advantages of the radial network. So that is why you see now in our problem also we want to find out one network which from a mesh network which will give a less voltage drop, okay, overall less voltage drop, as well as which will give which will give that which will give us that a radial network also. Now to determine that one, what we have to do? Now you see in our network we are having some loops, right? So now we are considering here that x1, x2 as well as till x19, they are the switching status of the line, and that xi value is indicating the switching status of the ith line. Now xi is equal to 1 or 0. So here xi either it is 1 or 0. So these two values only there. Okay. So now see, suppose if you think about x1 and x2, that x1 means it is connected between line number 1 and 2. Just can you if you see the line number 1 and 2, so to make a mesh free network for that particular loop, so we have to turn on the switch, we have to open at least one switch, either x1 or x2 switches, either x1 or x2 switches. So you see the x1 which is connected between bus number 1 and 2, so either we have to open that switch, or x2 which is connected between 1 and 5, we have to open that switch. That means, see, if you make a loop free network, if you make a loop free network for this one, which for this part, then either we have to open that x1 or x2. So that is why we are given the value of x1 and x2. It should be greater or equal to 1. It should not be more than 1. So at least one switch at a time will be open, and other switch should be closed. So that condition we are given by this way: x1 plus x2 is greater or equal to 1. Similarly, if you think about x12 and x19, that x12 and x19, x12 is connected between 6 and 12, and x19 is connected between, in between 12 and 13. So now, if you to make a loop free things, we have to open at least one switch, So that is why we are given x12 plus x19 greater or equal to 1. Now I am giving you one task. Can you check the condition of 10? Can you check the condition of the 10? Can you check the condition of the 10? Can you check the condition of the 10? We are given x12, x19, x20 and x17 is greater or equal to 4. What it indicates? To make the system radial, we have to put that conditions. So now I am just giving you one task. You please check that conditions. You are having the network. Just check this. Check this is condition, whether my conditions is okay, whether my inequality condition is okay, or something wrong is there. Can you check that one? And we have given some condition that x8 not equal to 0. That means the switch which is connected there, the switch which is connected between 4 and 7, between 4 and 7, you see there may be one, there may have some transformer. So that is why we are not opening that switch. That is why this should not be 0. That is why we are putting that is not equal to 0. So just I am giving you few minutes of time to check about this constraint of the equality. Can you please check with respect to our problem? Just few minutes, 2-3 minutes. Can you check it, please? Just check that conditions. Check this condition, whether that figure is visible to all of you, as well as that that table is visible to all of you.
Yes, sir, visible. It is visible.
Okay, so can you please do that equations, that inequality equation? Can you check with respect to figure? If you are able to do, then I will be satisfied. At least you have learned that way. So please do that one. Check that equations. Can you do? Just I am giving you few minutes time. Just few minutes time. I am giving you few minutes for check. Anybody has done that equations? Anybody has formulated that constant part? So I hope that you are able to do. Our main concern is that we should make that equation such that it will give some physical significance, that there will be no loop, as well as no node should be isolated, or no bus should be isolated from the system. So that two part we have to keep in mind while we are making the radial network from a mesh connected network. That time there should not be any loop, number one, and number two, no node will be isolated from the system. That two part we have to keep in our mind. And our main objective is what? That we have to minimize the overall bus voltage drop, right? Overall voltage deviation from our rated bus voltage. So this is our main objectives. So now as a researcher, okay, your main objective will be what? Your main focus will be building of your mathematical problem, right? So building of the as well as the problem formulation. So if you have the mathematical problem with you, nowadays in number of optimization tools are available in the internet, right? You can utilize any of the internet, any of the model, any of the techniques, and you can solve that one, and you can get publications also. But only the thing is that you have to modify your problems, introducing your new things only, introducing your new additions of some extra problems. Means suppose I have considered that three part, like voltage division, as well as the mesh network, as well as the loop free network and isolated node, and you can consider some other factors also. You may consider less power loss also, less active power loss also another objective, and you can consider less reactive power loss also another objective. You may consider some other factors also, some congestion. Sometimes when we are making from mesh network to radial network, some lines may be overloaded, right? So that condition also you can put there. So in that way you can increase the complexity of the problem. So once if you increase the complexity of the problem, you can easily get very good publications also. Okay, so shall I proceed to my next slide? I hope that you have made that mathematical problem formulation. Is it clear to everybody? Okay, so I am moving to the next slide. So for genetic algorithm, what we have to do, we need to give some initial population. as our first step is initial populations. So we have to give some initial populations. We have to give some initial populations, and and for that purpose what we did some manual reconfiguration, right? So yesterday we did some case studies where we did some manual configuration, and from that manual configuration, if you are changing the switching status, 1 indicating close and 0 indicating open, so by changing the switching status, what would be the over all voltage deviations, that part we are calculating. Okay, using load flow technique we have calculated, and that part we are given as a initial population. Here some sample of the some small data which has been shown here, that for initial populations of the GA. So this is some sample part, and based on that we have given the populations of the genetic algorithm. So now after that we have fixed some parameter in the genetic algorithm. So we have fixed the crossover probability, then mutation probability, then crossover. These two we are fixing, and at the and that other part also, like that iterations also we have given, as well as the that so for initial purpose we are given that P0, P1, P2, P3, from P0 to P19 we are having 19 lines, and for 19 lines what is the power, that power we have given. So we have given that Py, that is what Pi is the active power loss of the ith line, and Ri is the reactive power loss of the Ri is the resistance. So what we did, we are giving for genetic algorithm, what we are giving, that first different switching status, and for that corresponding that value, right? So so these data initially we are given as an input. Okay, so after that we will get some output for after 3-4 iteration run, we are getting some output. Okay, so initially we are given such kind of input, these input as a population part. So now after running this code, after running this GA, we are having some code, and that in that code, while we are running that one, we using that that value, that crossover probability, as well as that mutation probability, for different the value of that one, we are getting in the different value of the losses, of the line losses, as well as the switching factor and corresponding the voltage deviation. So now that means what, if we have that initial populations, then based on that population we can easily get the voltage deviation part. So for different crossover probability and mutation probability. So after running some 3 iteration, we are obtaining such kind of data. Okay, is it clear? Do you have any query? So now I am just summarize the complete things what I am telling you. First, you see, we have to make some initial populations from our test systems. So in our case, test system was a IEEE 14 bus network. So in that 14 bus network, after running the load flow for different switching configuration, we are obtaining in the each of the line power loss, as well as the voltage drop of the overall system. Now after that one, you know, after that thing, what we did, we are encoding that things, means that data as per the as a process of genetic algorithm, you know, that data has given as a initial populations, and then after that that data, while it is giving to that genetic algorithm part, so now by now for different, you know, crossover probability and mutation probability, they are randomly generating the solutions. So solutions for what? Solutions for different configurations for overall, for the different line losses, as well as the different for that corresponding voltage deviation part. So in this way, we can find the optimal configurations also using that that generating algorithm, where the voltage drop will be less. That means we can easily determine a radial network from a mesh connected network, which will give us the optimal, you know, voltage deviation of the network. So this is about that genetic algorithm application uh, for network reconfiguration. So is it clear? Is it clear to all of you?
Yes, sir.
So anybody have any questions? Please ask me, because after that I'll go for another techniques. So for this network reconfiguration, what we did first, you have to formulate the mathematical part. Then based on that, you have some constant. You have to, and you need to generate some data which can be given for initial populations. After initial populations, we using genetic algorithm for different crossover and mutation probability. After some iteration, we can get different, you know, different combinations of the switching, for which corresponding line losses as well as the voltage deviation, and from that the best solution, the best chromosome, that the best structure of the chromosome, that will give us the optimal solutions, which is having the less, you know, voltage deviations of the overall systems. So this is the overall things. Now if you have any question, please ask me. After that I'll go for the next topic. Is it okay?
Yes, sir.
Then I need some questions from participants.
Participants, if we have any questions, sir will be pleased to answer.
Yeah,
So
please.
participants are requested to raise the questions. Sir, it seems that participants are not questions are not there. So you can go ahead, sir.
Okay. Thank you. So now I am going to the next topics, that is called. Now the next part is application of neural network for improvement of the voltage stability. So neural networks, just a minute. Hello, my voice is audible?
Yes, sir, it is audible.
Okay. So, the neural network is a toolbox which can be used as a function approximator. So they have an excellent ability to approximate a continuous function based upon few available sample values. That is, ANN can evaluate and approximate a smooth curve even if the data supplied to the network is discrete. So now,
అంటే ఆడ అప్రూవల్ కావాలంటే
artificial neural network is a toolbox
500 పార్టిసిపెంట్స్
where we are giving some
కంపల్సరీ
input, known input and known output,
1 year కి
and based on that they can make one model. And after this, that means we are giving some input and output initial level. That is called the training phase of the artificial neural network. So once it has been trained, after that, for any unknown output, if we give any of the input, we can easily find that one nicely. Now, our network reconfiguration problem is a very complex and non-linear network, non-linear problem. Why it is complex and non-linear? Because network reconfigurations means we are having switching status, which is in discrete in nature. Wherever our output we are generating as a power loss, active power loss, reactive power loss, as well as the sometimes we are finding voltage stability, sometimes we are finding voltage deviation. These are some different types of value. It is not like discrete means type of value. So that means we are dealing with we are dealing with different type of data here, right? So that switching status is a discrete type of things and our output is a continuous type of things, right? So now that dealing with that two types of integer, that mixed integer is sometimes a difficult task for any of the model. But our neural network can also perform that job nicely. So basic structure, here. So this is a very good approximator. Any mathematical function, the neural network no need any kind of enter information, but requires only few discrete data points lying on the function graph. So that means what is here saying, that means in neural network, in our present problem, what is happening? If we have say 100 number of lines, then we are having how many possible configurations? 2 to the power 100 minus 1. But manually we can generate hardly 500 data, 1000 data, but we cannot generate 2000 2 to the power 100 minus that 1000 number of data. So we can generate some small amount of data using manual configuration. Based on that, we can give the data as a neural network as a training purpose, and rest of the things neural network can predict for any of the configuration, whatever the other part. So for neural network, for our present problem, how it is effective, that part we have to think here. So we are having a huge a set of data whose volume is huge, and out of that we are giving just very small amount of data for neural network, and that will predict for our unknown input. So neural network can solve the network reconfiguration problem. And in that case, what we are doing, we are giving as an input is as a dynamic states of the switching status, and output as a voltage stability indicator of the overall system. So the basic structure of a neural network is what? We are having some input, then after that some activation function is there, then output is there. So input and outputs are there. So in between, sometimes the neural network may be a very simple network. There may be less number of hidden layer. So sometimes it is maybe single layer, sometimes it may be more number of hidden layer. So in figure 5.2 it shows that we are having only one layer, and in in 5.3 we are having multi-layer. So we are having 3 layers, total 4 layers, right? So this is the some structure in our network reconfiguration problem. We have used a feed-forward network configuration, feed-forward network for predicting of the voltage stability for different configuration problem. So the basic structure of the neural network is what? We are having input neuron, up that input is given to the neuron. After that it is total sum of these things can be done, and that summation is given to the activation function, and based on the input of the activation function, this activation function is giving some output. So in our case we are utilizing, you see. So now in activation function there are many types of activation function. Out of that log sigmoidal is there, then tan sigmoidal also there. So we have shown that one for different input what would be the output that is given here. This tan sigmoidal or that function can be utilized as our transfer function. So now for our case, what we did, basically our objective of the problem was that we want to find out the optimal configuration which is having the less voltage stability and less loss. So for doing such kind of things, initial level what we did, we are having the ANN and we are giving different switching states as well as corresponding their voltage stability as a training purpose. Then after training that one, we are giving unknown data as an input. For that we are predicting the voltage stability for unknown for some other configuration. Now in our configuration, what we did, basically we have given for our system data, we are having 14 by system data. That data we are given, and after that we made some load flow solutions. So that load flow solution give us the data for training purpose. So that data is given for training purpose. So that is given to ANN for training purpose. Now after once the ANN has trained, then what we did, we are having total 19 number of switch. That means that switch configuration may be 2 to the power 19 minus 1, that configuration 2 to the power 19 minus 1. So now for each of the configurations we want to find out of the voltage stability index. For that we have made one algorithm which and using that algorithm we made one small code which is generating the n bit, that a 19 bit switching status. Now suppose if you have say n number of lines, that means we have to generate a code, switching code which is starting from 000 to all the 1, and one by one they can generate that code, and that is given as an input of the ANN. And while it is given as an input at the ANN, and that output has been stored that output has been predicted using ANN, and after that we have to make here one small code that what is there. We are just comparing that voltage stability index with previous one. If it is being less than that one, then only it is kept. Otherwise the old one has been stored there. Okay, so in this way what by comparison itself we are checking the best one. Now suppose after say thousands number of that generation, thousands number of iterations, after, let us consider we are having one problem of of say a 5 bus network, so a 5 line network. Instead of bus, I am thinking about the system which is having 5 number of lines. That 5 number of lines means what is there? You may have total 2 to the power 5 minus 1 configuration. So that means it may have how much? 31 configuration, total 31 configuration. So our switching will start for our generation of the that 5-bit switching. It will start from 00 to all the 1. That means total 32 number of the configuration. So one configuration is given as a input, and corresponding output we are getting for voltage stability. Suppose for all the 0 configuration means all switch are closed. For that we are having some voltage stability. Then we are making all 0 except one switch, the last switch, that LSB only 1. So LSB only 1 and other switching status is 0. Let us consider. So we are having total 5 bit, just LSB only 1 and other is 0. Then for that also we have to check the stability, and now we are comparing that stability index with our previous one, while all are 0. Now if this one is better than the earlier one, then this will be stored in a particular memory. Then after that what we are doing, after that the next switching status will come and it will compare with that one, the present one. Then once again in this way we are making it till 32 number of configurations, and based on overall configuration status we'll find out the which one will be better optimal network. So this is about overall algorithm. So now just this is some code, and just so now after after running the code, this is showing how our training has been done. You see, whatever our the training curve, target output versus ANN output for the training data. So these axis, y axis is our target output and x axis is our ANN output. You see, it is a straight line, and it indicates that it is perfectly trained. The system was perfectly trained, and as well as you see that if you see the error, how it has been minimized after 7th iteration itself, you see that error has been completely minimized, right? So that means you see, if you have a very good training data, you can easily train that one, and it can be trained nicely also. And so for our case study, you see our target output versus training output showing very nice, as well as the error also reducing fastly, and very sharply it is reducing, right? So this is about our different configurations, switching configuration and corresponding. You see, in this case we are calculating the stability index for different configuration. That thing has been given in that one. Some of the uh, data has been given for a training purpose, and after training we are obtaining the best result. So to solve such kind of things, we have to initially we have to give some training data. So so in our case, we are putting it as a, you see, we are giving different x1 x2 till x20. It given as a it given as a input for training purpose. Okay, so for one input means one string of the switching status, another input means another switching string, and corresponding output also we are given as a target value. Based on that, we have made the training, and after training, for any unknown input, so these are all unknown input, mean unknown switching status. For any of the unknown switching status, we can easily calculate this voltage stability index. This is L index, means some voltage stability index we are calculating. So from that we are obtaining that that configuration is the better one. That one, this configuration, which is given 0.2858 L index. Yesterday we have discussed about overall line index. So that line index value lies between 0 to 1, 0 indicating in the most stable, 1 indicating unstable. So if a line index value nearer to 0, it will indicate it is more stable. So from our case study, we have found that that star indicated configuration will give the better voltage stable configurations. So is it clear to all of you? Sir, is it anybody having any doubt, any questions from any doubt? Anybody have any doubt, any query? So anybody have any doubt, any query?
Sir, myself Chandrababu, sir. I have one doubt, sir.
Please tell me, sir. Please.
Can I ask?
Yeah.
Sir, that training and testing both are important. Validation also important for ANN, sir.
Yeah,
and
yeah,
that is
yeah.
depends upon the number of samples, sir.
Yeah.
In that switching pattern, sir, we have less number of samples, sir. How you can get accurate?
Yeah. See, I'm telling you here, you are rightly pointed, right? So suppose for these problems, we if you just consider about that our 14 bus network, right? In the 14 bus network, we are having 19 lines, right? So that 19 lines configuration will start from all the 0 and end with all the 1, right? So all 19 0 and all 19 1, end with all 19 1. Now if you make the training only for, say, first by changing the switching only, say S1, so we are having the switching status from S1 to S19. So you have to make your training data set not only for by changing by S1 to S4. Okay, so you have to make a training set where your switching status will be changed from S1 to S3, then some of the data when S3 to S7, then as well as S5 to S10, like that. That means if you think about, we are having a complete data set in A zone, B zone, C zone, D zone, complete data set. You have to find all the zone data, means some sample, small sample of all the zone data, means you have to make a training data set by changing in almost all the switching. Maybe, suppose if you have say 3 switch, what would be the possible combination of the that one? So 2 to the power 3 will be the possible combination. That means 8 minus 1, 7 possible combination. Now, so for a particular 3 switches, at least you can generate out of 7 one configuration. So in our case, 2 to the power 19 means we may have total configuration is 2 to the power 19 minus 1. So from so now if you categorize the complete data set into 5 domain, means 5 domain means first domain will change the first 4 switches, second domain will change will give the second 4 switches, the third domain will make the third 4 switches, and the fifth domain is the last 4 switches, like that only. So you have to collect the data, sample data from each of the domain, then only your ANN will be nicely trained. So now in our case, I have shown you just a few sample, but in practical we have done lot of we have trained it number of data. Thank you for your questions.
Yes, sir. Thank you very much.
Any other questions? Anybody have any questions?
Yes, sir.
Yeah, any questions, sir? Any questions?
Voice is not audible, so just wait.
Hello, my voice.
Sir, tell me.
Hello. Yeah. Any
Yes,
other
sir, yes, sir.
questions?
Voice is
Any other questions from the participants? I'll be happy to give you your answer.
Oh. The participants will respond.
Okay, sir. If no questions are there, then what I can do?
Yes.
I'll just take 2 minutes time for loading another PPT. Then I'll
Yes, sir.
start.
Go ahead, sir.
Okay,
Go ahead.
just I'm taking few
Okay.
minutes time for loading another
Okay.
PPT. Okay, just.
Go ahead.
In between, if you have any questions, you please ask me. I'll give you your answer.
Okay.
That star indicated configuration will give the bit. Hello, my voice. Hello. Yeah. Any other questions from the participants? I'll be happy to give you your answer.
Hello. Go to the origin. Okay. Immediately.
Participants
Okay, good morning once again to all of you. So now in this session, what I'll discuss, I'll discuss about the applications of the machine learning for network reconfiguration. So here you, we have utilized some two types of machine learning algorithm for network reconfiguration problems. In network reconfiguration,
Hello? Hello?
you know that we are changing the switching status,
Validation.
and if you are changing the switching status, sometimes what happen, the system some of the configuration may not be feasible. Sometimes some of the configurations also it's not giving the optimal solutions also. So now, based on the stability criteria, means voltage stability indicator, we can check the status, health status of the network. Normally in distribution network, for a particular distribution engineers, when they are doing some work, online work, they need some information, immediate information to run the systems. Okay, so for that purpose, see, as a researcher, we may develop some kind of toolbox through which they can get some kind of information for a particular system before the operation. If they have the proper training data, if they made the proper model, right, then prior to the operations they can check a particular configuration whether it is effective or not effective. So this part already been discussed in earlier discussions about the voltage stability indicator. So I'm just skipping that one. So now here we are assessing the voltage stability using some machine learning model. So here in this discussion we are using k nearest neighbor algorithm as well as decision tree algorithm for the stability assessment purpose. So if we want to find out the status of a particular configuration prior to the operations, we need some models. So for that purpose only, for online operation only, this model can be utilized. So so the machine learning also, what we are doing there, it is like it is a subset of artificial intelligence only. So we have to give some initial input as a training purpose. After training only, for any unknown data we can get the output, we can predict that one. So sometimes the machine learning can be used as a regressor problem, or it may be used as a classification problem. So now in our case, see what we are doing, what we are thinking, that that we are classified our entire operations, the distribution operation by three different class. The first class is that the normal operations, then intermediate operation, then emergency operation. as you know, the value of the stability indicator, if it is lies nearer to 0, that means the system becomes stable. If it is lies nearer to 1, it is unstable region. So now, based on this, based on this idea, we have classified that entire operation into 3 different classes. The first class is normal operation when the value of the VSI lies between 0 to 0.49, and intermediate operation is between 0.5 to 0.69, and emergency operation is when it lies, uh, under 0.70, means if it is less or more or equal to 0.70, that means it is going towards unstable region. So a operator should know about the status, the operating conditions of the power system where it is running. So we are introducing loads to the systems, and sometimes some loads will be more, sometimes we are having a unbalancing between active power generation as well as the load utilization. Sometimes we are having mismatching of reactive power generation, reactive power utilization. So now if such situation will arise, that time what happened, that stability point, that stability value, voltage stability value will be changing. And for a particular loading condition, what would be the operating state? So a power engineer should know at online conditions. So if he has all the data with him, based on the data he can easily find out that status. So here we are trying to find out the state for a particular conditions, loading condition, based on the machine learning algorithm. So just so first of all, we have used some k nearest neighbor. So it is basically some algorithm. So the basic principle of the nearest neighbor model is to obtain the predefined training unit nearest in a range to a new position and predict a level from this. Neighbor-based regression may be employed when the levels are non-continuous. We estimate the level specified to depend on the average of the k nearest neighbor level. So now suppose if we have some data of switching, as well as if we have the voltage stability part. So we have for our problems, what we did, based on the different configuration, we have made the entire data into 3 different class, and that things has been given initially. So we have some data, and that data has been given for training purpose. In k nearest neighbor, when we are giving this data, so that switching status as well as the voltage stability part. First of all, we have to choose the value of the k. K means for a particular unknown value, means for k nearest neighbor case, what we have to do, we suppose we are having some data, and in that data, suppose we want to find out we want to predict for unknown data. So that data we have to put it there along with all other data, training data, and now we have to put some value of the k, and based on the value of the k, they will what they will do, nearby we have to put our some unknown value of the input there, and based on that input for which we are going to find out the predictions, they have to find out the distance of the nearby distance of the data which is nearer to that nearer to the that unknown predicted that point, right? So now they are finding the distance based on Euclidean model, and sometimes they can do suppose if we have say some data point like x1 y1 x2 y2 x3 y3 x3 y3 like x4 y4 and x5 y5, then what they can do, we are having some unknown predicted data, like let us consider this is some a1 b1, then they have to find out the distance between all the data, all that data, and they have to calculate that data, that distance also. Okay, so they have to, now the first work of that unknown predicted point or data, they have to find out the nearest 5 points and which is available near, and once they are finding the nearest point, nearest 5 data, if for this is for k equal to 5, once they are finding that nearest point, then after that they have to make the averaging of that data, and based on that they can make the, they can determine the value of the predicted data. So here that is why first of all what they are utilizing for k neighbor regression model, they have utilizing that averaging. They have to, first of all they have to determine first their nearest 5 points, and from that they are making the average, and that average value will give you the value of the predictions. So similarly, in decision tree also can be utilized for classification problem. They will start from root node and end with the leaf node. So now from one node to another node, how they have to go, they have to find out the entropy for finding one node to another node, and from after getting the entropy, from there they have to calculate the gain value, and after getting that gain value they can determine the root also. So that too is very much important. So after getting that one only they can make the model. So now these are the some configuration of the 14 bus system, and it is the switching configuration. So now this is for 30 bus network, this is for 30 bus model. Now so now see, so we have given some data. So as I told you, to train such kind of things we have to give some data, and that data comprises of what? The voltage stability index, that active power loss and reactive power loss. Based on data we have categorized that things into some classes, like normal class, then intermediate class, then emergency class. That thing has been given here. So based ESI value only we are calculating that things, whether it is coming under normal or intermediate or emergency. Now we are classifying these things into now for any unknown data we can easily classify that thing, whether it is coming under normal zone or intermediate zone or emergency zone. Okay, so
పిల్లలు ఉంటారుగా అందుకని మీరు అడిగిపోతే నేను నాకు ఇద్దరు పిల్లలు ఉంటే ఇబ్బంది అబ్బా అనేది అదే.
So now after training that one, you see we have been checked check the performance of our comparison. So for any of the machine learning, to check about the model, we should have some confusion matrix, and based on that we can check whether system how much it is accurate, how much applicable for that particular problem. So now for that one we are having some metrics. That metrics are uh, like that matrix are accuracy is there, accuracy is the matrix which is given by true positive, true negative, and divided by true positive, then false positive, then true negative, then false negative. Then that means that accuracy can be calculated based on this value. That means true positive and true negative, true positive, false positive, true negative, false negative. Now with respect to our problem, I am explaining what is true positive, what is true negative. So just you see that first of all we have to go to our matrix. So you see we are having what we are having that three states, right? This is the predicted, one axis is representing the predicted, another axis is representing what, another axis is representing our actual value. Okay, so when our actual value and our prediction value both are same, that is called the true positive. When our actual value and our actual value and our predicted value, okay, sometimes both are same and sometimes maybe some difference will be there. So based on that, that is finding by true positive and true negative, right? So now if you see that one, that all these diagonal part, this is about what, this is about that positive value, right? So now we are calculating the true positive, true negative, and true positive, true false positive, true negative, false negative. So I'm giving one case. I'm giving an example of a case. Suppose our prediction for a particular system is normal condition, and our in actual also this is normal condition. Then that condition is called the true positive, right? Now suppose our actual is not normal condition, but prediction is actual is negative condition, and our prediction also negative normal condition. Actual is normal condition. Okay, now suppose our actual is normal condition, but our prediction is false condition. Then what is happening? Then this is not a true positive thing, right? So now so our predictions and our our actual condition, when both are same, then that is called true positive. Okay, now suppose our actual condition is emergency conditions, then our but our prediction is telling say normal condition, then this is called false negative, right? So in this way this part is coming like that. So after doing the analysis, we are having we are getting some accuracy, right? We are calculating the accuracy. See, this accuracy is giving for our KNN model, it is coming 0.799 accuracy, and execution time was 0.7, whereas the decision tree has given more accuracy, which is coming 1, and execution time, but for this case is 0.3. Okay, so this is the performance comparison of the two model. So now this is about the decision tree, that confusion matrix, and this is the true level and this is training level. So this is for decision tree algorithm, and this is for k nearest algorithm. Now another evaluation matrix is precision. So through precision also another matrix through which we can assess the model things, as well as recall also there, through which also we can find out. So based on these three only we can calculate that F1 score. That F1 score also another matrix if we have the precision value and recall value, from that only we can easily calculate the F1 score. So this is some evolution model, evolution of machine learning model for normal, intermediate and emergency condition. What is their evolution matrices, that thing has been given here. So from that we are observing that decision trees F1 score is better in some cases from KNN. Okay. So this is the region of the convergence, RC. So while we are doing the decision tree, that time what we have to do, we have to make we have to calculate our entropy, and from that entropy we have to calculate the gain, and based on that only we are getting that 3. Then from that only we are getting different types of layer. So that layer we can get it. Okay, so this is about, so first of all we are taking Q loss less than or equal to that one, entropy value that one, sample, and from that we are getting value, and then when class equal to normal we are getting such kind of things. So these are the internal tree structure for the proposed decision tree algorithm. So after that one, after training and testing, we have found that for k nearest neighbor it will take 80, and that is 80 seconds, and testing time 0.7 seconds, and decision tree 65 seconds, and for training time and testing time 0.3 seconds. So this is about mean square error and standard deviation also. We have calculated that one, and we have seen that decision tree regression are given better results here. So this is for the first, this one for 14 bus network, and this is for 30 bus network. So basically what we did, basically we have calculated calculated here the stability index first, and we did here also, we have applied here a KNN regressors model as well as the decision tree model to find out the switching status, whether it is coming under normal or intermediate or emergency conditions. And after that we have calculated the performance of the two machine learning model based on confusion matrix and with their matrices, okay, like precision and other matrices, F1 score, accuracy, with that one. So this is about this applications part. I hope that if you have the machine learning model, you can easily solve this kind of problems. And in machine learning, there may have some other classification model. You can utilize the same problems statement for that also. Then you can get a good publications also. It is useful for you also. So do you have any questions in your mind? Hello?
Yes, sir.
Yeah, please.
Participants, any questions? We can continue. I think they're not No questions from this side.
Okay, no questions. Acha. So, okay, sir. If no questions are there, then I can just give you actually some other solutions. Means I'll give some presentations of network reconfiguration using some other optimization techniques, right? So I'm just sharing that things. For the time being, you just give me just 5 minutes time. I will just share that things. Okay.
Okay, sir.
పక్కన ఉంటాను
ఏమో కూర్చో.
అత్త అన్నావు అనుకో ఆయుష్యం అయితే నేను గుత్తి గుత్తి చంపేస్తాను అనుకుంటున్నావు అయ్యా అందరికన్నా ముందు పని మీ అక్క ఆయన తెలియ తీసుకో మమ్మల్ని నీ అల్లకి అక్కడ తీసుకో నాతో కాదు
కూర్చోరా, ఇది నీకు
సార్ మరి నాది నేను రిజిస్టర్ వచ్చానా సార్ నా పేరు
చూడలేదురా నేను అసలు.
నా సర్టిఫికేట్
అందరికి
వచ్చిందా
ఇస్తాను, అందరికి ఇస్తాను.
నువ్వు ఇచ్చేదండి నువ్వు ఈ పని నీ పేరులో నా పేరు
ఓ ఆయనే చేసిన సర్టిఫికేట్ నువ్వు ఆయనతో గొడవ పడక కూర్చో.
నాలుగు సర్టిఫికేట్ నాలుగు కొట్టుకున్నాను నాకు మా నరేషాకి ఏమి చేయను రండి సార్ అండి నేను ఇప్పుడే క్లాస్కి వచ్చాను ఉదయం నేనే నాకు రిజిస్టర్ ఇచ్చాను सर मेरे भी लिया आप सर अच्छा इसमें
So
అన్న నువ్వు ఉన్నాయా ప్రాజెక్టులు ఉన్నాయి ఏంటి మన ప్రాజెక్టులో మన పేర్లు వస్తాయా నువ్వు చేస్తావా డాడీ
So good afternoon to all of you once again. So now I am just discussing about that network reconfiguration through hybrid based graph theory methodology. So uh, so in that applications, what we are doing here, we are using the optimal power flow, and based on the optimal power flow, we have to find out the value of the cost matrix of the graph. And in my earlier class I have discussed how, based on the load flow solutions
చైతన్య
which
సాయంత్రం 6 పీరియడ్ ఉంది
give us the power flow, maximum power flow for a particular line,
నాకు
that data
మార్చారు కదా
can be utilized
ఫ్లాష్ అయింది బీసీ
for
ల్యాబ్ ఉంది ప్లస్ ఆడ ఏడిఎస్
cost matrix purpose. The same now, instead of that load flow, we are utilizing the optimal power flow. So optimal power flow means what? You know,
బాగోదులే
నాగరాజు
we have to check, if you are running the load flow, we have to check for what conditions we are getting what the power loss of the overall system will be lost, for what voltage, what angle of the buses the overall loss will be less, active power loss as well as reactive power loss. This is basically one optimization problem. Optimal power flow basically one optimization problem. We have to check, we have to run, we have to find out the load flow solution for what the power loss, active power loss as well as the reactive power loss will be less, as well as your voltage will be more, right? And subject to some constraints that you are having some line loadability limit, subject to that constant. So in our present study we have taken 30 bus network, and for that 30 bus network we have found the optimal power flow. So based on the optimal power flow solutions, we obtain the cost matrix, means line data, and after that line data, that data can be utilized as a cost matrix, and then we have utilized that one for different graph theory part. Like we have utilized maximum spanning tree, we have utilized Prince algorithm, and there as a cost matrix we have utilized that data. So then what is our overall logic? So first of all, obtain the OPF data, implementing of different algorithms. So this is about one of my work which is which is doing my student. So they are utilizing some optimization techniques. So you can also do the apply the optimization, and you can find out the optimal power solutions. And for the optimal power solution, you may have different toolbox in MATLAB. So you can utilize that data there for finding the load flow, OPF load flow. After getting that one, you can determine the cost matrix from that, and you have to determine the cost matrix as you have seen in my earlier class. So you have to find out the line flow through each of the line, and that will give you the cost matrix. And after that you have to find out the spanning tree algorithm. You have to check the spanning tree algorithm. You have to utilize spanning tree or maximum spanning tree you can utilize, and from that you can after getting that thing you can find out the stability as well as loss for that particular configurations. So as I have already been discussed there, that that power flow through a line can be given by Vu Vy x in into sine theta u minus sine theta u minus sine theta v. So suppose if you have two nodes u and v, then how much power will flow through that one? That can be given u was voltage, v was voltage, then their the reactance of that line, that is xuv, and sine of the difference of the sine of that line you have to find, and from that you can easily calculate that thing, right? So now this is for our 30 bus network switching status, where switch 1 is connected between bus number 1 and bus number 15, like that. In bus number 1 and 2, switch 1, and switch 2 is connected between bus number 2, 3. Similarly, switch number 15 is 22 is connected between 15 and 18, like that. We are having total 28 number total total 28 number of switches. So we may have 2 to the power 28 minus 1 configuration. Are you imagine what is the numerical value of 2 to the power 28 minus 1? It's I think 2 to the power 10, 2 to the power 10 into 2 to the power 8, like that. So 1024, 1024, 1024 into 1024 into 2 to the power 8 means how much? 64, then 128, then 256. I think 2 to the power 8 equal to how much? 2 to the power 8. 2 to the power 8. 2 to the power 5 is 34. 6 is 128. It's coming almost, I think. So yeah. So if you want to calculate 2 to the power 28, how much is coming? It's coming 1024 into 1024, then into 2 to the power 8. That amount of configuration. So that so now from that configuration you have to find one optimal one. Now for that purpose, what we are utilizing both optimal power flow as well as the graph theory. So that optimal power flow will give you the cost matrix which is required for the graph theory. So what we did that one means so for that we have given such cost matrix there, and after putting that one they are giving some case study using that. If you are utilizing the interior point method, it will give that that value is 0.7198 per unit and 2.008 per unit. Okay, so this is giving the corresponding active and reactive power loss, and as well as the voltage stability is coming 0.1457. So if we utilize the interior method using the Prince algorithm, so we are utilizing for optimal power flow interior point method using MATLAB, and that cost value has been utilized in Prince algorithm. After doing that one, we are getting the power loss 0.71938 as well as reactive power loss, that one, and voltage stability also 0.1547, and corresponding the network configuration will be like that. So here dotted line indicating we are opening that lines only. So we are opening that line, we are making the system radial one only. From mesh network we are making it radial only. Okay, by by opening that lines. Dotted line means that corresponding switch has been opened. So the graph of these things, graph of this network will be looking like that only, which has been which can be obtained by MATLAB. So now if we utilize the quadratic programming method, sequential quadratic method, as well as Prince maximal spanning tree, then we can have some different result, right? So for that, if I utilizing the that sequential programming method, for that network will be like that only. So similarly, their graph will be like that. So MATLAB biograph, if you utilize, you can get the graph of the network also. So then if you utilize the Prim's algorithm, but if you find out the optimal power flow with active set, so with active set method, if you make the optimal power flow and if you utilize that cost in Prim's algorithm, you can get some different data. So for that corresponding network reconfiguration will be like that only. So and corresponding graph will be like that. So now if you compare these three different methodologies, see, we are utilizing only Prim's algorithm, but we are utilizing different type of methodology of optimal power flow. We'll get different type of radial configuration which is having different types of losses and different types of voltage stability. So you see, so for Prim's algorithm, Prim's maximum spanning tree with interior method, we are having voltage stability as well as loss like that. Now if you have sequential programming, you are having the different data, stability index also there. Now you see, for different methods, okay, if you for different methods, if you utilize the different types of interior method, the different types of algorithm for optimal power flow, we are obtaining different types of power losses and reactive power losses. We can utilize QISCET also for that one, and Edmonds algorithm also. So we have already been discussed that part. We can compare that result with our present study. Then we have seen that if you utilize the optimal power flow for this configuration purpose, it will give better voltage performance, better result only. Okay. So this is some comparison, that graphical comparison. This is some graphical comparison. So where it has been given like that only. So this is some so different types of things. You see, the voltage stability is how much, as well as real power loss, as well as the reactive power loss. This is the comparison for different approaches. So from that you can see that if you utilize the Prim's maximum spanning tree with interior method, you have seen what are the different types of losses as well as the stability indicators. So for you can see that the Prim's maximum spanning tree is given better result. So is it clear to all of you? So we have utilized the Prim's maximum spanning tree along with the optimal power flow using different optimization techniques, and we have found the different types of output in terms of voltage stability as well as active power loss, reactive power loss. By comparing all of these things, we are obtaining that Prim's maximum spanning tree will be the better one. Is it clear to all of you?
Yes, sir.
So anybody have any doubt? If you have any doubt, please ask me. Okay. So for optimal power flow, what you have to do, you have to formulate your problems and you have to run the program using any of the optimization techniques. So in MATLAB, you may have a number of optimization toolbox. You can utilize that one also. So but before that you have to formulate your problems for optimal power flow. If you go through any of the textbook, you can get that things, that optimal power flow. Okay, it is easily available. So now with this I am ending my these sessions. If you have any question, you may ask me any question if you have.
So participants, you may ask any questions, and we can also speak a few words about the sessions also. Though participants are welcoming to speak few words.
Any question from your side?
So it seems no questions from them.
Hey, that means you are not hearing properly.
No, no. It's some new concepts, for them. They take some time for them to understanding. We will share the entire video to the participant also, sir.
Yeah.
They can get.
So I need at least some questions from your side.
Yes, yes. I will speak few words in this session. Especially special thanks to Dr. Tipu Sarkar sir for coming forward to help us to the institution to organize this FDP program. Sir is very instrumental, key person in providing the resource persons also to us. Thank you, sir, from the bottom of my heart and on behalf of QISCET, on behalf of Department of EEE, for extending your wholehearted support to us in conducting this FDP, sir. So we covered a lot of excellent various topics, the presentation, the information provided. Hopeful that it met the expectations of all the participants who joined in this session. Like network reconfiguration, artificial intelligence technique, machine learning, graph theory, etc., etc., sir. Very valuable information you provided, sir. Patiently also you explained each and everything to all our participants. Thanks a lot for sharing this such type of valuable information and for participating in this valuable workshop also, sir. You provided a great resourceful information. You were a very resourceful person, sir. Thank you to all the participants and to you especially, sir, for conducting these sessions. Thanks a lot, sir. Thank you very much, sir. Have a good day,
And
sir.
thank you, sir, to all of you. And sir, I want to share just one information to all of the participants.
Okay, sir.
See, presently, our institute has given some advertisement for PhD admission. If anyone willing to join, they can join. They can join with scholar for full time as well as part time also. So many faculty member are there. They are guiding lot of PhD scholar and awarded also many number of students. So if anyone is willing to join, they can communicate with me also from electrical background. If they want to do any of the work, particularly in power system domain, not only network reconfiguration, I am working on different domain. You can go through my Google Scholar profile, you can check it, and if you think that anything is matching with your domain or is suitable with you, you can directly contact with me. I'll share my that email ID to all of you. Okay, and apart from that one, for your research purpose, future research purpose, if you need any kind of help, even though if you are not joining NIT Nagaland, if you are doing anywhere any of the work, you just communicate with me without any hesitations. Even sir, for your department also, if any of the UG project you are conducting, if you need any kind of help, any kind of guidance from my side, UG, PG, anything else, I am ready to support you.
It's a great opportunity to all the participants, sir. Thank you for giving valuable information to the participants also.
And one more thing, if they want to come for any of the internship in future, for this NIT, they can communicate with me prior to that one, and I can arrange for them for any of the internship,
That's great, sir.
summer
That's great.
internship as well as winter internship, anything else.
That's great, sir. Thank you, sir. Thank you.
Oh,
Thank you.
thank you.
Thanks a lot. Participant, anyone want to speak? Can share few words. Sir will spend lot of time with us, even though sir is quite busy with a lot of works. Okay, sir. It seems all of them are busy.
Right.
So thank you, sir. Thank you.
Thanks a lot, sir, for giving me opportunity to interact with you people.
So especially I should say this is the opportunity to special thanks to our friend Chandrasekhar, who is always strong supporter
Yeah.
to us, sir. He's
Yeah,
a very
he's
good
also
person.
supporting.
Yeah,
Always.
he's very good person, sir. I'm seeing him from the last 10 odd years. So very strong support to me, especially from him, sir. Thanks you.
Right. And he is one of my best
Yes.
student, and he's working also nicely. I
Yes,
hope that very soon you can see some of the very good journal paper.
Yes,
from
sir. Yes,
his
sir.
side.
Thank you.
Oh, thanks.
Thank you, sir. Thank you. Have a good
Okay,
day.
sir.
Thank you,
So
all the
I'm leaving.
participants.
Yeah.
Thank you, here I'm leaving. Participant, please give your valuable feedback. The feedback link is shared in our WhatsApp group. So you can share your feedback. That will be very useful to us in guiding us in conducting such type of sessions. Thank you. Thank you all.